Solar flares are powerful bursts of radiation from the sun, often accompanied by coronal mass ejections, CMEs, that hurl charged particles into space. When these energetic particles interact with Earth's magnetosphere, they can trigger geomagnetic storms, disrupting satellites, power grids, and communication systems. This has led some to wonder, could solar flares also influence Earth's seismic activity? Scientific studies have explored potential correlations between heightened solar activity and increased earthquake frequency. The idea stems from the fact that geomagnetic storms induce electrical currents in Earth's crust and mantle. In theory, these currents might influence tectonic stress along fault lines, possibly nudging them toward rupture. Some research has found weak statistical links between solar maxima and clusters of earthquakes, but the evidence remains controversial and inconclusive. Earthquakes are primarily driven by tectonic plate motion and the buildup of stress deep underground, forces far greater than electromagnetic disturbances from space. Still, solar activity may play an indirect role. For example, changes in Earth's ionosphere caused by solar flares can interfere with seismic monitoring equipment, complicating earthquake detection. Additionally, solar-induced stress could, in rare cases, act as a minor trigger if a fault line is already critically stressed. The broader scientific consensus is that while solar flares impact Earth's atmosphere and technology, they do not directly cause earthquakes. However, ongoing research continues to examine subtle interactions between solar and terrestrial systems. Understanding these connections may improve our ability to monitor both solar weather and seismic hazards, especially as human society grows more dependent on vulnerable technologies. In short, solar flares are a reminder of how interconnected Earth and the Sun truly are. But tectonic forces remain the dominant driver of seismic activity on our planet.